Hello and welcome. Today I'm going to present to you a quick look at the state of Georgia's energy resources and needs, both now and into the near future. Taking note of many sources Georgia uses for their energy demands, the goal of this presentation is to evaluate the energy profile of today and see what improvements can be made in anticipation of expected state growth. In addition, the future energy profile will take into account the use of more sustainable resources to help balance the current high use of traditional resources compared to that of the renewables. Some questions being considered for this project include what is the current energy profile for the state of Georgia, what energy sources are available domestically for use and which are being used, environmental problems associated with these current sources, the expected energy needs for 2032, and also as we create a future profile, we need to see about viable sources, diversity of sources, if they're environmentally friendly, and if they can help in reduction of greenhouse gases. Here are some current energy stats for Georgia. Right away we can notice that in terms of BTUs consumed per capita as well as energy expenditures, Georgia ranks lower than the mean average for the U.S. They have lower energy expenditure costs than most of the country, 39 of 50. As well as BTU consumption for their energy requirements per person. But they also have a fairly high carbon dioxide output, 137 million metric tons. That's enough for the 11th highest in the country. And as seen below, the transportation sector consumes the most energy out of all the different energy sectors in Georgia. And that is probably because of the amount of cars and traffic and commuter traffic, especially in the city of Atlanta. The other thing is that in terms of renewable resources versus traditional resources, Georgia leans more towards the traditional aspects, not using very much in renewable. Some graphics later on will help further illustrate that. Here's a chart of the electricity production in Georgia on a monthly basis. Natural gas is the highest source for electricity production, followed by coal. Also worth noting is that coal and natural gas are both imported into the state. There is no domestic production or use, so they are reliant on other states providing them resources and even other countries, especially for natural gas. Nuclear is also produced in state, but is also expected to increase in capacity as there are 2 new reactors under construction, and there are some renewables as well in terms of the hydroelectric power, as you can see in the non-hydroelectric, which is more biomass and a little bit of solar. Coal is expected to continue dropping over time as natural gas replaces it. A couple charts outlining the energy consumption in Georgia. The first one outlining the 4 sectors breakdown of energy consumption, with transportation leading at 29%. And the second chart just giving more of a generalized breakdown of energy sources and consumption, with natural gas leading the way at almost 700 trillion BTU. This is an expected value with the electricity use for natural gas as well as the heating capacity for natural gas. Also worth mentioning is that the motor gasoline is the second highest value due to the high amount of traffic and commuters in Georgia, predominantly in the Atlanta metro area. More of an in-depth breakdown on the resources in Georgia. We'll start with the renewable resources first. Georgia has a very high biomass potential. They are the rated number one nationally in terms of commercial woodland. There's a lot of different forested areas in Georgia, and that leaves for a huge capacity for a bigger tap into the biomass market, which is currently being used to some extent, but not on a bigger utility-wide scale that it could be. They do have hydropower in use. There's 30 dams statewide, and we'll talk more about the water use issues later. Solar is also becoming an element in terms of utility scale production. Just last year, the first solar plants were really starting to come online. For conventional resources, things like fossil fuels, they don't really have any production capability for coal, oil, or natural gas. Again, those are imported into the state in order to provide energy values. There are nuclear power plants produced in state, used in state. It's the only non-renewable generation using state resources, and there are 2 new reactors coming in the future, which will help with the nuclear generation capacity. Of these sources, it's definitely apparent that there is a high reliance on conventional energy, and a future plan will try to help bring in more renewable resources to kind of offset that reliance on conventional. Two figures to help illustrate where some of the renewable sources are. The first figure on the left kind of outlines where the dams are in Georgia, predominantly on the Chattahoochee River in the west, and then there's some mountainous lake regions in the north. And then, of course, on the right, there's the biomass energy potential. Georgia's down there in the southeast in the circle, in the very green areas, which is pretty common for the southeast. There's a lot of woodlands there that have potential to be used. With the current energy profile, there are some environmental concerns to take note of. A big one is the air pollution from vehicles in Georgia, particularly Atlanta. A large amount of the petroleum energy in Georgia goes towards gas for vehicles alone. It's the number 2 source of energy consumption behind natural gas, so it's a very critical component that needs to be accounted for. Still using fossil fuels for electrical generation. Natural gas is better than coal, but it still is a fossil fuel that produces high emissions. Biomass, in addition, is also producing emissions. It might be a carbon neutral source of energy, but the debate between carbon neutral and whether or not it actually is better for the environment is still a debated topic. Also, water use throughout Georgia is still definitely a hot topic due to the ongoing disputes of uses between states and with domestically. More people using the water means that there's going to be definitely more concerns about water quality. Talked a little bit already about the expected growth in the near future. Georgia is definitely expected to grow, looking at about a 20% increase in population by about 2030. That puts it at around 14 million people. Most of that growth will take place in the Atlanta metro area. In terms of energy demands, however, for residential and commercial demand anyway, the growth will be offsetted by more efficient technology in buildings. So the energy demands will stay relatively similar to what they are now, even with the increased amount of people. Industrial demand, however, will go up, but there will also be an increased energy demand overall because the efficiencies that were listed for the residential and commercial aspects will not be enough to offset that. So we're looking at about a 20% increase in energy demand by 2030, looking at a few charts that had that as about the average scenario value. So looking at some of the values that presented before, in the case of industrial, it's about 27% of our energy generation. So if we're looking at about 20% increase, that means that we need an additional 700,000 megawatt hours in production. These are the projection charts that were referenced in the previous slide. We're looking at around the 2030 time frame, and as you can see in the first chart, the projections show fairly stabilized values for residential and commercial fuel consumption. And the second chart, you can see that the values, even in the best and worst cases scenarios, are going to go up. And taking an average of those values puts it at about a 20% increase in power. With this information, we can make a profile for the future, with the future energy profile. For required generation, there'll be an increase in industrial demand, which will require more electrical generation than is used today. There'll be a reduction in coal use for electrical generation. There'll be an increase in nuclear capacity as well as natural gas generation, especially to help offset the reduction in coal. The new renewable generation will take effect as the biomass market is expanded, as well as solar playing a more prominent role in energy generation. With the increased renewable resources and nuclear generation, greenhouse gases will be reduced considerably, and the replacement of coal with natural gas power will help limit the potential CO2 outputs. Two charts, one with the 2017 energy output and one with the projected 2030 energy output, to help illustrate the changes in electrical generation. Now that the new profile has been presented, we will discuss the reasons for the energy choices made. An important goal for the future is to reduce overall greenhouse gas emissions from a multitude of sources. Coal is one of the dirtiest forms of emissions, and replacing coal with natural gas will lower these numbers. If possible, coal's use as a source for electrical power should be rid of entirely, with much better options in the future. Renewables are the future, however, but there still needs to be more time for development that allows them to become an integral part of any power plant. Until then, there must be other options to supplement their current limits. Georgia already has a high amount of natural gas use, and by 2030 it will still be a major component of power generation, especially in this plan. As mentioned previously, other sources are not viable enough to let natural gas be retired as an option for energy. Nuclear, while controversial, is already being used in Georgia and provides a great way to make clean power effectively. It won't be the final source for power in the future, but it meets the needs of today while also allowing energy to be generated without greenhouse gas implications. It will effectively bridge the gap until renewable energy sources can be established. Lastly, it's important to ensure the source diversity, and while natural gas is proportionally the most needed used source, there are other sources available to keep the profile viable.